Internet, Matt Gentleman here, Senior Solutions Architect at GitLab. Today I want to talk to you about leveraging the power and efficiency of human habits to increase the quality of your work life. 5 things we're going to talk about today in making secure development practices into a frictionless business as usual type habit. First, we're going to get inside the typical developer habit loop. Second, we're going to talk about how context and timing is critical to forming new and positive habits. Third, we're going to talk about transparent responsibility, motivating engineers to do the right thing, just simply by building it into your existing software development habits. Talk about collaboration and real-time learning mattering in context of when a developer is working on code, why it's so important to be able to collaborate and learn real time about security findings, and also discuss briefly only when necessary type approvals, reducing friction and noise as part of the software development process. So let's get started. Let's talk about what many DevSecOps organizations do. They do the do-it-yourself or start-from-scratch type development tool chain. The do-it-yourself tool chain looks an awful lot like a Rube Goldberg type machine. On the left, we have the post-integration process trigger that's manually created, which has to trigger a static application security testing, dynamic application security testing, and fuzzing security test stuff, which when it works is wonderful, which then calls some kind of a vulnerability collaboration tool, which fills a bucket full of balls and pulls down the scissors and produces reports, which then slams the boot down in production deployment on the stapler to staple a staple. This sort of approach is wonderful when it works, but what it hides is the fact that all of these steps and separate tools in a DevSecOps tool chain need to be maintained and need to be kept up to date and need to keep working in concert with one another. A better approach is to start with a platform-based approach, so a single software machine that enables you to plan, collaborate, build, scan, test, and deploy, as well as monitor your software delivery. A platform isn't good enough. What you need is actually a platform that is extensible. That means flexible or able to be customized. Let's talk about shifting architecture left. Externalizing undifferentiated functionality through platforms and frameworks that abstract non-direct customer value creating code. So to give you a quick example of what an abstraction is, let's start with the Ruby language. In the beginning, when Ruby first came out, everything was a brand new piece of code in Ruby that you had to write yourself. As open source contributors started building more and more patterns that emerged into libraries, Ruby introduced the idea of Ruby gems. Those libraries that are able to be reused over and over again so that you don't have to write everything by scratch in the Ruby language. Those gems eventually created the Ruby on Rails web application framework and a series of other Ruby type frameworks that exist. That means today, people writing Ruby for the first time can learn a framework and leverage that framework and don't necessarily need to write everything from scratch. Amazon Web Services has done roughly the same pattern. At the bottom of the screen, moving up, we can see Amazon Web Services started with resilient and reliable compute infrastructure that you had to deploy from scratch. Eventually, that matured into reusable application parts, or as a platform as a service offering, and there's just 6 of many that AWS offers. And finally, AWS today offers entire frameworks. So AWS Amplify, application building as a service. So you don't actually have to start at the lowest abstraction. You can start up at the top on Amazon Web Services. GitLab has done roughly the same thing. We began down at a low level, writing some of the manage, plan, create, verify, package, secure, release, configure, and monitor type features of our software as a service product. But eventually, we've created a platform that includes an intelligent CI/CD type framework. So you can start with an entire platform and you don't have to write or customize each and every stage of your software development. Not only do we write a platform, but we also have an extensible platform. And that means that we have a platform that is flexible, changeable, and exposes a rich set of standard APIs to help enable custom code as you need to deviate away from the platform prescriptive-based approach. So when we talk about shifting left on this screen, we're actually shifting ourselves up the screen, right? We don't need to start at the bottom of the screen anymore because frameworks, application building as a service, and an entire development platform exists today. There's no reason to start cobbling things together. As you shift things left, starting at the top instead of starting at the bottom, this sort of approach scales with customer business success. In other words, businesses see value starting at the top. All right, what is the power of an extensible platform? First, let me talk about the anti-pattern on the left. Traditional shops, the do-it-yourselfer type approach to shops, start with these small custom nuggets first, right? They're writing everything by hand from scratch. What ends up happening is this leads to a large custom code base, which of course is great if you're a startup company or you're do-it-yourself. You have more time than you have money. This is a great way to start something new that's never been done before. Unfortunately, this also leads to over-engineering of our DevOps journey. So we spend a lot of engineered time, but not a lot of money, creating this large custom code base. Today, in a platform-based approach, or platform-first adoption, let's talk about the positive pattern on the right here. We consume the platform capabilities first, which means we don't need to write a whole large custom code base, and instead the customizations are simply where the platform opinion differs from our workflow or our process. So it minimizes the amount of customization and extensions that you actually need to deviate away from the platform. We call this lean engineering of a DevSecOps type journey. And the lean engineering starts with a platform-first development approach. This is a shared value between GitLab and Amazon Web Services. We both philosophically see the world in roughly the same way. We'd rather consume an existing platform first and then write extensions that deviate or customizations that deviate away from the opinionated platform's opinions. You're going to hear a lot of shift left stories, but GitLab is fundamentally different in that it focuses on an empowered developer experience to reduce friction and make security deficit remediation a business as usual type habit. Shift left has gotten mixed reviews in the online social media platforms, so let me explain roughly what we mean here about an empowered shift left. If we ask managers to help solve some of our slow software development lifecycle practices, they're going to come up with a human-based solution. As engineers, we want to have this responsibility, the tooling, the timing to be a systemic type process in shifting left, so that if we developers are responsible for taking on more operational type work, that we are responsible and the right reminders and habits are formed as part of a systemic process using the tools. Of course, training and collaboration, along with approvals built into a workflow as part of a systemic approach, are something that most engineers and most developers and operations people want to see when they're taking on more responsibility. Let me use an example from another discipline outside of software engineering, specifically the hardware engineering discipline. If we take a look at this particular iPhone in the hardware-based development process, we traditionally have many presenting problems, and it takes many people and teams, all of the people on the screen here, to fix all of the various hardware issues when the phone has already been manufactured. For example, perhaps the camera needs to be able to have a better upgraded lens. Perhaps after some user testing, we find out that the flash next to the camera needs to not just be an LED that momentarily flashes, but would also be useful as use of in a flashlight type context. So there would be a change out of the LED for an LED that can be steady on or be flash. Perhaps the radio antenna is not quite the right frequency band. Perhaps a 5G network has become available after we manufactured the initial prototype of this cell phone. This traditional big ball of mud context diffuses the responsibility and is poorly timed for resolving a number of many presenting problems. And as you can see, if we discover these problems late in the hardware development process, 3, 6, 7 people and multiple teams have to be involved. Involving all these teams in a number of presenting problems late in the hardware development process compounds the issues. A better approach would be to simply discover these problems as the phone is being manufactured. Perhaps the white bearded gentleman on the left is an expert on cameras and could easily change out the lens that is used on the camera and correct that problem before it is presented as a finished product. The individual in the middle perhaps is an LED expert and could easily change out the flash-based LED for a steady-on LED. And the individual on the right could simply change out the frequency wavelength of the antenna before the phone is assembled and produced. And that is exactly what GitLab wants to do with computer software. We want to identify the problem in its context as it's being designed by the designer or developer or engineer who is presently working on the problem before the problem is compounded into a finished product. Shifting left means that we use the internal motivation of the person presently designing the particular hardware feature in this example to be able to quickly and easily pivot and upgrade the hardware device before it's manufactured into a finished product. So what does that have to do with habits? There's been a lot of excitement and writing about the power of habits in recent years. Science has proven that habits are a fundamental part of the software and hardware of human brains. There are known techniques for building good habits and known techniques for destroying bad habits. I want to talk to you a little bit about habit stacking. First, a habit fundamental. It has to be an obvious, routine, and within context with a reward. That's how we form good and bad habits. Habit stacking is a fairly new concept that has been recently introduced. It's a special form of implementation intention. Rather than pairing your new habit with a particular time and location, you can pair it with a current habit. I like to think of this as perhaps a current routine. So this method, which was created by B.J. Fogg as part of his Tiny Habits program, can be used to design an obvious cue for nearly any habit. For example, after I pour my cup of coffee each morning, I will meditate for 1 minute. After I take off my work shoes, I will immediately change into my workout clothes. After I sit down to dinner, I will say one thing I am grateful for that happened today. After I get into bed at night, I will give my partner a kiss. After I put on my running shoes, I will text a friend or family member where I am running and how long it will take. Again, the reason habit stacking works so well is that your current habits are already built into your brain. I call these a routine. You have patterns and behaviors that have been strengthened over years. By linking your new habits to a cycle that is already built into your brain, you make it more likely that you'll stick to the new behavior. Once you have mastered this basic structure, you can begin to create larger stacks by chaining small habits together. This allows you to take advantage of the natural momentum that comes from one behavior leading to the next. It's easy to think of code as only a computer thing, but in truth, humans have been codifying all kinds of knowledge for centuries. There is one type of human knowledge that is more like computer code than anything else, and that is process execution knowledge. Let's talk a little bit about the typical software development lifecycle flow. And first, we'll talk about the anti-pattern. So, for example, if our team had a number of security findings in our code base, and we went to management and asked management to help us manage all the security vulnerabilities, oftentimes a process may be added to an existing process when it should just simply be modified. First, the anti-pattern. A reminder in context is not visible. For example, a security scan that comes much later in the software development process and is not automated or systemically automatically triggered and has to be done or reported on by a separate group or a separate human being. This leads to difficult engagement with the idea of trying to scan our code for security findings. It also means that vulnerabilities are reported later and out of context, like after the phone was assembled. It makes fixing those security findings arduous. Communication and unclear code responsibility about who has to be tasked with fixing them. The reward for this is unsatisfying, and the effort put forward to resolve the security problems goes unnoticed. This leads to a non-formation or a dismantling of any habit, including vulnerability remediation, as part of your regular day-to-day work. Let's talk about the positive or a better approach. So let's say we had a reminder to run a security scan that was in context with our day-to-day software development activities. In other words, it was systemic. It was part of what we do. That contextual reminder every time we committed code, for example, or pushed code, would be an obvious contextual reminder. Well, an obvious contextual reminder leads us to a routine and very easy engagement with security findings. In GitLab's world, our GitLab flow workflow simply treats security findings as a build failure. So security findings are just another routine defect that happens as part of while we are assembling the telephone or while we are presently working on the code. If it's easy to engage with, it forms a routine or a positive habit only if there's a satisfying reward. In GitLab, a green light or a clean build leads to a satisfying reward. That is the formation of a habit and a routine. You do this set of steps over and over again, and a habit or routine or way of working on your team is formed. As you can see, we remediated the vulnerabilities as we were doing our day-to-day work, because security vulnerabilities were just simply treated as another software defect, and we formed a habit that results in vulnerability remediation happening. This is one way you can delight a developer, because a systemic approach where the reward is built into the day-to-day work no longer makes remediating security vulnerabilities a janitor or come back later and clean it up sort of task. By building in the vulnerability remediation as part of our day-to-day work, we actually create a situation where security vulnerability is a frictionless part of what the team does. It's internalized. Part of the remediation discipline avoids both the cost and the work-life stress of having external management have to fix things after they are deployed. Here you can see the core stages of the DevOps lifecycle. You have planning, code creation, all the way through to monitoring. And also shown are just some of the tools that can be potentially used at each stage. As this chaining together of tools comes at the cost of integration complexity. You need resources to design, build, and maintain the integrations, manage updates, and establish high availability and disaster recovery for each one. A cobbled together Rube Goldberg machine approach is a brittle approach and is easy to fail. Setting up a new project or troubleshooting and optimizing an existing project becomes difficult and is too slow for today's demands. And as the tool chain only serves to reinforce silos that you're trying to break down in the name of DevOps. Instead of teams being able to collaborate together, their different tools put them in different workspaces. Let me show how GitLab flow is slightly different. In that first plan and create stage, GitLab has built into our platform the concept of epics, milestones, issues, and the ability to assign an issue or pick up an issue, the kinds of things that a traditional project manager might do, and that last thing, assigning or picking up an issue, might be an activity a developer would do. In the integrate and verify stage, GitLab allows a developer to create a feature branch off of the mainline development branch by creating a merge request or developer single source of truth. GitLab so fundamentally believes that we should create a merge request right away at the beginning before we start developing any kind of code that we've built it into our workflow. We believe that merge request is a lightweight promise by a developer that the feature branch they are creating and the work that they are doing is going to be short-lived and merged back into the mainline branch in a short period of time. If you've ever worked at large enterprises where collaborative features or polls are done after a feature branch is created, then you're probably familiar with the monthly, quarterly, or semi-annually abandoned feature branch cleanup event that has to take place. If you're in one of those places where you've had the unlucky assignment of being the person to clean up feature branches that ended up never being merged back into a mainline branch, then you understand the pain that I'm talking about. That's why GitLab believes right away we want to open that merge request, a place to collaborate, automatically creating a feature branch, and a place to push our code, a safe sandbox to work in. Because GitLab takes a systemic approach, our platform automatically does a build test of your code. And when you have the features enabled, you have a development environment created automatically for you when you create a branch and every single time you push code to that branch. As you can see here, this particular automated build automatically builds and deploys to a series of different Amazon Web Service instances via Terraform. And thus, a developer can go and look and see what changes they are making and how they will impact the actual feature and functionality of the product they are working on. Because we now have a running environment of real running code, GitLab can run a dynamic application security testing or DAST scan against the running software application. Things like unsanitized user input, buffer overflows, things like that can be detected using our scanning feature. We also have a fuzz testing feature as well that is absolutely mind-blowing. Our fuzz testing features hit your running application with non-UTF-8 characters like emojis, emoticons, characters from other languages, things that perhaps your users may try or an attacker may try to run against a running application. The fuzz testing feature finds security vulnerabilities or unsanitized user input is just one example that have not yet been discovered by open CVEs or open security findings on the web. I encourage you to go and look at getting started with GitLab application security and a series of videos we have on GitLab's Unfiltered YouTube channel to learn more about fuzz testing. It is absolutely mind-blowing. After all the three big security scanning, static, dynamic, and fuzz testing are run, we use the merge request as a collaboration and review point to allow people to work together to make sure that the change the developer is making is the direction you want to go with the code base. And because we've built the collaboration, scanning, automated build test that happens automatically without the need to contact another team and ask for a development environment, since this happens systemically and automatically, we've created a frictionless vulnerability remediation setup. So we get immediate and relevant feedback only on the code change or feature branch we're working on. It's timely. It's like the hardware folks on the left side of the screen on our previous slides discovering earlier on before the phone was fully assembled. And a directly responsible individual or subject matter expert has the associated feedback they need on security, code quality, and the changes they're making in real time as they're working on the code. This changes your team's development habits and makes the vulnerability remediation part of the normal coding habits because the feedback is immediate. After reviewing my code change, my team could ask me to push and do a number of commits and push fixes. And when I do, an amazing thing happens. Of course, the development environment is repushed and recreated and retested and collaborated on. And eventually, after several commits and iterations, my team and I decide that we have a working piece of code and it gets approved. The approved merge request can then be merged, either automatically or manually, back into the mainline development branch. The moment it gets merged back into mainline, I no longer need to have my development environment. And so GitLab automatically cleans up that feature branch environment because it's no longer needed. Either automatically or gated manually, you can trigger a release and have a production deploy that matches your mainline branch. As you can see, this sort of approach leads to much quicker continuous integration. It also remediates your vulnerability and your security vulnerabilities and treats them as a software defect. And our approach is an extensible type approach, meaning it's flexible. If this is not how your team works, you can deviate from this type of approach and make it work for whatever security scanner, whatever environmental or different cloud provider or on-prem type deployment methodology you use. Ultimately, GitLab can integrate using this pipeline feature with just about any other third-party tool you can imagine. We have a number of integrations already built into the product for popular pieces of software, and you can write your own integrations for anything we don't have. Ultimately, this leads to customer value because we have a single platform approach here. So under the monitor and improve included in with our product, you can of course monitor your production deployment, see how the code is operating, see the response times, see all the types of metrics you would expect to be able to monitor in a running application. Now, if we take one step back and go back to talking about our managers for just a moment, we can also figure out where our teams overall are spending large amounts of time or are getting muddled in not being able to improve the flow of this workflow. We at GitLab use value stream metrics to help us understand and improve how we can work faster and do more continuous integration, continuous development, and continuous deploy. Let me show you briefly what the merge request page looks like. We want to strike a balance between not too warm, not too cold, but just right amount of information at the right time in the development process. So a just-in-time type approach to be able to figure out if the changes I'm making as a developer on my branch are impacting the security of our mainline branch. What you see here, specifically on the lower half of the page, is a number of new vulnerabilities have been detected in the change that I made on my feature branch. These are not every vulnerability that exists on the mainline branch, but rather the difference of what work I am doing on my branch and how it is changing the security posture of our overall running application. Because I'm given that just-in-time oversight, I can go ahead and decide whether I need to correct some of the high, medium, or low vulnerabilities that were found, or if I can seek approval from my security team and ask them to be called in and attempt to merge even though I have a high vulnerability severity on this particular merge request. We think of the merge request as a collaborative place for multiple teams to be able to work together to find a balance of usability, security, and reliability. Again, this is all up to you if you want to configure and to what degree you want to configure things like our license checking features. Some companies like a particular software licenses to be included and others not to be included. This is configurable and flexible. In other words, fully extensible. So if your company has approval rules and groups, perhaps you have a separate security team that reviews the types of licenses, the types of vulnerability, whether or not a site reliability engineer has been included in on this change. You can seek approvals and or overrides from those teams to get your feature pushed off to production. Also, if you have an existing security scanner, as many of our customers do, you can bring your own scanner extension if you'd like. You can have GitLab triggered as part of a pipeline and thus keep the history of all your security scans from the past. We also have the concept in GitLab's platform approach of enforcing approvals for newly detected vulnerabilities. Here we can see me customizing the configuration of a new approval workflow when the approval is required. I can also specify which users or groups are eligible to approve. For example, my security team may need to approve a vulnerability going into production if we believe that is a risk that we want to take on as a balance of part of deploying a new feature. GitLab is able to enforce any number of approval type workflows that you're willing to configure inside of GitLab that are appropriate to your software development practices and your business. In all things human, context and cues are very important in forming and maintaining habitual behaviors, routines. Books on habits are filled with this information. Human habits are a form of automation. So using systems automation to encourage human habits seems like quite a natural approach. It has been said that environment or rich context is the invisible hand that shapes human behavior. On the left, GitLab's what we think excellent approach, a systemic approach to forming a new habit within the everyday developer habit loop or workflow for code changes made just moments ago. Only newly introduced vulnerabilities are immediately visible and directly associated with the individual or directly responsible individual, or DRI, or subject matter expert, with a semi-private remediation opportunity. In other words, a merge request tells me that I have introduced a new security finding. And with auto remediations and on-demand training, a per vulnerability full collaboration capabilities, the remediation management or responsibility defaults to the individual developer who is presently working on that feature. Now let's talk about the anti-pattern, the traditional way we remediate through management instead of through a system. Traditional remediation management lacks the context, the collaboration. It comes too late in the cycle. It's an addendum process that can be forgotten or skipped sometimes. The moment of introduction can sometimes be unknown. Maybe we'll scan the code when it's done being developed. Maybe we'll scan the code after it's already been deployed to production and running for days or weeks. All the vulnerabilities are already committed to your mainline branch. They're in your code base already. It also means delayed scanning, reporting, and it's unclear who is the author of a particular security and who has the code authoring responsibility of fixing that security. It may take more time and effort for someone not familiar with that part of the code base to go back and fix it. It also leads, in running software, especially in a production environment, to a panic or alerting everyone type behavioral pattern. So in this particular context, the remediation management defaults to either your site reliability engineer, your reliability team, your operations team, or maybe the security staff. Many of our customers come to us asking how they can develop better DevSecOps maturity practices on their team. And there's a number of ways that are traditionally created for going after a management-based approach to planning out a pre-planned future higher maturity level of DevSecOps. For example, on the bottom is time. We have today. The first milestone may be in 3 months, the second milestone may be in 6 months, and the pre-planned higher maturity level 3 quarters from now, or maybe at the end of the year. To a manager or management type approach, DevSecOps maturity usually means more teams leveraging more scanning types more often for more of the code lines for more of the languages in your growing total code base. A typical management approach would be to simply add another tool late in the process, which of course adds to your existing tool set complexity. Of course, it costs time and money to implement that tool, so sometimes contractors are brought in to help make that happen faster. So we end up hiring more people whose job it is just to run and implement the security scanning tool. The developers, of course, will take more time to learn a security scanning tool that comes later in the development process. And, as we saw in the Rube Goldberg machine earlier, multiple stacks to administrate and patching and upgrades may not happen simultaneously. So maybe your security tool gets upgraded, but your pipeline tool is still on an older version. The natural thing that happens then is that the code base begins to grow. The usage pricing of all of the tool set complexity and all these separate Rube Goldberg style DevSecOps tools starts costing you more money. And we barely pass milestone 2, and the non-automated process, in other words, the human-based process of multiple teams handing off to team after team through a complicated workflow, basically means you might achieve milestone number 2, but you'll never get to a higher maturity level with DevOps. If I put a line through all of these particular approaches or events that end up occurring as part of the do-it-yourselfer DevSecOps, I can also put a vertical bar on the left-hand side of the screen. Those engineers listening to me now will recognize this curve as a logarithmic type growth curve, not linear. So for the business folks, the do-it-yourself DevSecOps can result in a compounding penalty for growing in your DevSecOps maturity. Instead, when you adopt a single platform like GitLab, you end up seeing a linear growth in your total cost of operations. So here we see we've achieved the pre-planned higher maturity level sometime in the future later, and the growth of cost is linear and not logarithmic. That means that instead of spending money on multiple tools and managing lots of licenses and a special remediation team, we can take that same money and hire more developers who can then add more features to our code base. GitLab's total cost of operations is linear, predictable, and connected to value-generating activities, and creates an empowered shift left onto developers. See, here we've hired more developers and don't have a need for a separate remediation team, tooling, or even contractors. So today we covered in this talk about habits, how to transform a secure development into a business as usual habit. We got inside the developer habit loop by creating a voluntary remediation habit, because vulnerabilities are simply treated as just another software defect. We've learned that context and timing is critical, because we'd much rather detect security problems while we're developing the software way before we deploy it to running in production. Transparent responsibility motivates a developer. When it's clear and visible responsibility, it creates a habit, a repetition, and self-motivation to correct those security findings as part of the development process. Using GitLab's merge requests, we saw that collaboration and real-time learning could be in context as part of the software development branch that I created as part of my day-to-day work. Keeping that in context with the change I'm proposing to make is a catalyst towards getting me to learn a new method and being able to collaborate with my team, which then gets the approval and gets my code merged back into the mainline production branch of our code base. And finally, we learned that the only when necessary approvals reduce the friction and noise. So the approvals you saw back on the merge request screen only showed up when the security team needed to override or approve a security vulnerability I introduced. If I don't introduce any new security vulnerabilities, I don't need to seek approval from my security team. By reducing the friction and noise of not needing that approval, it meant that I could keep my cost curve flat and linear and not have that cost go logarithmically out of control. I want to thank you for your time today. You can find me on the internet, on GitLab.com as at mgentlin@GitLab, on Twitter or X as at mgentlinonops, and on LinkedIn as Matt-Gentlin-327-986-230. Thanks for your time.